welcome to Advent of Code in F star. This is day 7. Happy Advent. It is not only Advent of Code, it is also Proc Jam this week. Proc Jam is a programming jam. It's also a game jam to make something that makes something. It is the lowest effort game jam ever. It's too late to start early, but you can run late. They're looking for submissions for their zines. There's a lot of interesting creative work. Check out the Proc Jam tag on Twitter to see people's projects. As I mentioned, this is day 7. I've managed to get 2 stars and everything so far. Let's see if my luck holds up. The language I'm using is called F star. It's a research language out of Microsoft Research. It's a functional programming language, but it supports imperative models as well. And most importantly, it supports reasoning about programming, reasoning about effects. So you can prove things about your program by encoding them as types. And it's got a very general type system and an effect system that lets you do that. Advent of Code is sponsored by my employer, Akita Software, this year. I'm very happy that we're sponsoring Advent of Code. I've enjoyed participating for many years. Akita's hiring right now. We're looking for front-end and product engineers, back-end engineers. We're looking for a developer advocate, although that job is not listed. So check out our jobs page, and love to have you come work for us. I did want to talk about one thing from yesterday. I think I closed it up already. One of the lemmas that I proved last time was, I thought, going to be simple, and it turned out not to be. What we want to show is that if we split a string into 3 parts, so give it a list and an index, and get back this triple, the substring before, the sublist before, the individual element we named, and everything afterwards, we want to show that we can put in a replacement and append everything together and get back the same length that we started with. And so the way I did it is I said, well, split 3 is implemented in terms of split at, and we've got one lemma from the standard library about that, and one we can write. And then we've got a lemma in the standard library about how long is a string once you append it. How long is a list once you append it? It's the sum of the individual lengths. I was kind of puzzled why there weren't more useful lemmas about split 3. And it turns out there were. I was just looking in the wrong library. Split is defined in the module F star list tote for total functions, but the lemmas for it are actually in F star list pure. And so once I found it there with grep, then I could rewrite that lemma to be a little shorter. Not a whole lot, but this approach would not require me to write this whole other lemma. So there was support in the standard library. I just didn't know where it was. So we've got about 5 minutes left to go. I want to just show something that's been tripping me up in F star. Example. All these are checked in, although not well documented. I guess I put it in. I put it in day 4's code. So the types in F star are not covariant. So the natural numbers are a subset of the integers, but a list of natural numbers is not a subtype of the list of integers. So if we try to execute this, it'll say, hey, the subtyping check failed. These two types aren't related. So there is a way to make this work. Let's see. So it's in, but you have to be explicit about it. So there's a function called unref, which stands for unrefined. So you can take a list that's got a refined type and convert it to a list in the base type. And this looks like it's going to be horribly slow because, hey, isn't this just copying the whole list? And the answer is no, because that module actually has a direct OCaml file backing it. So f star dot underscore list tote base. And if we look at the translation of listref, it's just the identity function. It's not actually doing a copy. So this is sort of a hack in the fstar implementation where we can prove something inductively that is true, that we can convert a list of some refined type to a list of the base type. But when we extract it as code, it doesn't actually apply the overhead of copying the whole list in order to make that work. So next time I run into that, I need to remember that that function is there and that it doesn't actually have any runtime overhead. So I got my giraffe t-shirt on today. It's a balmy 4 degrees in Minnesota where I live, and projected to get colder yet tonight. So hope we can stay warm using our brains here. My solution yesterday actually got the highest rank yet for part 2, even though I wasted some time on part 1. I did want to show, how much time have we got left? Less than a minute. I did want to mention that there's a way to make that solution even more efficient by using matrix multiplication. You can set up the transitions between the different number of fish as a transition matrix and then use repeated squaring instead of strict iteration. So if we had wanted to do thousands of iterations instead of just hundreds, that would have been worthwhile. Unfortunately, fstar does not have a nice powerful numeric library like NumPy in Python that makes that easy for us. So that would have been a lot of work. We'll see. Some of the later problems in the year do tend to require that sort of optimization to do well, but we'll see. All right, here's day 7. Yesterday on day 5 we were dealing with squid. Now we've got giant whales. Okay. We have a horizontal position of each crab, and we need to find a way to make all of their horizontal positions match while spending as little fuel as possible. Okay. So I think it should be the case that their average is the minimum. Since if we move the spot left, everybody to the left of it goes down by 1, and everybody to the right of it goes up by 1. So is it the average or is it the median? Is it the mean or is it the median? Well, so say we have somebody out at 1,000. Say we got somebody out at 1,000 and 2 people at 1. Then what is that? If we move them all to 3, 3, 4, then that's going to be 6, 6, 6 plus 3, 3, 3 plus 3, 3, 3 equals whereas if we move them all to 1,000, that's 9 plus, that's going to be bigger. If we move 1,000, all right. Well, so this is the sort of thing it'd be very interesting to have a proof of, that the minimal solution is the mean, or else one to the left or one to the right of the mean. But I think it should be the case. No, it's not. All right. Yeah, because in our example, if we just move this guy, it only costs 999 steps to get him over to 1. Okay. But I think it is the median, though. Because yeah, I think the proof's like I said earlier, but I got it wrong talking about the mean. That if we start at all right, let's all right. What's our input look like? Pretty big. All right. So let's say we need our usual friends, IO and printf and all lists. So we can just copy our parsing code from yesterday. All right, so given a list of integers, okay, so, and meeting point, that's going to be an integer. And so that's going to be all right. If it's empty, then that's 0, and otherwise, we'll write the non-tail recursive version. Should be fine. It's head. It's the absolute difference between L and the head and the meeting point, plus some distance to the tail and the meeting point. All right. Learned my problem from day one. Let's not write the fancy tail recursive version. It might be harder to reason about. All right. So can we prove that? All right. And I'm a little worried about the case where the median is in the middle. I think it shouldn't matter. So F star does have a sort based on quick sort. So where is that? I've got sort with, which is a comparison base sort. Guess that's all we need. Oops. Yeah, there's a lot of lemmas about it. I see it in the F sharp implementation. Yeah, all right. All right. Yeah, that's a quick sort. It uses the first element as a pivot, which you know is bad in general, but I mean, bad in some cases, but right. I'm kind of puzzled. Like, is there a comparison function for the integer? So compare, right. Well, I just need to subtract them, and we get one order. I don't care which one it is, I think. All right, we're going to make an off by one error here. Length L. So if it's a 3-element list, this gives us 1. If it's a 4-element list, this gives us 2. That sounds right. Index. Huh. Um, well, that's not true all the time. Right, so if it's a 0 length list, then we don't have a median. So let's say this only works if length is greater than 1. Greater than 0? So S star, okay. Okay, it doesn't know that sorted and L have the same length, but lemma. Well, that shows it's a permutation. That shows it's sorted. But does anything show it's the same length? That seems like an odd omission. All right, let's just use Well, but even though that won't help us because we don't know that its length is greater than 0. Huh. I wish there was an index of F star lemmas. I'm thinking of building one, but F star's parser, while written in F star, does not seem easy to use. I'm spoiled by Go, where the abstract syntax tree is exported as part of the standard library. F star does have reflection, which might be good enough, but you can't scan through the source files. Could we use this to prove that the length is always the same? I don't see how. It seems difficult, even though it does fall out as a consequence. Oh, partition length. Where is that defined? Okay. So, all right. So let I'll write it for any type. Um, length L equals. We need to take the sort function. Equals sort with pair L. All right. Did we get equals length sort with compare L? Okay, so partition. All right. If length L equals 0, else. So this lemma takes a bool function. Okay, so that's why we use bool compare. Okay. So That's compare. Pivot is head L. Tail. Is that, oops. Is that enough? No. All right. So we need to say append length. Oh, we need to do this recursively. All right. Let's just copy the structure of this function. All right. So match L with K. Otherwise, I'll just call this F. I hate that it's F, but K. Equals. Um. Yeah, that's not gonna work. All right, so we've got two recursive calls for the two halves of the partition, and then we need to say okay. So we just copied that. That was kind of horrible, but all right. I feel like this should be there somewhere already, but we proved it. All right, so now our median's well defined. Length divided by 2 is actually in the string somewhere, as long as the length's greater than 0 to start with. All right. Now, can we prove that the property we want holds? So our lemma is median minimizes distance. Right, and the lemma is for all this is actually easier if we put this as another parameter rather than as a for all. So we want to say whatever z is, the summed distance to z is less than or equal to some distance to L median L. Right, so that's, if we had proved that, that would prove the correctness of our solution. And so if can it even prove the base case for us successfully? Yes. Oh, no. All right. Let's at least try to prove this base case. All right. So if length is 1, then we know that the median is the only element. Does index. Okay. So he knows that. And we probably need a lemma about this sum distance too, but okay, so maybe we should prove that it's always greater than 0. Another name for always greater than 0 is it's a natural number, greater than or equal to 0. All right, which it can prove inductively. Okay, so assert some distance to L median L is 0. That's good. And it should be obvious. let's just prove it for lists of length 1. All right, this seems like it's this is convincing to me. It's not convincing to F star yet. So what are we missing? We got our theorem backwards. Okay, that's an easy thing to miss. Okay, can it actually prove that all by itself? It can. All right. All right, good to know. All right, so all right. So there's our obvious base case. Okay. So can we prove this inductively? Um, it seems hard to say what effect an arbitrary element has on the median. I guess it moves it by either 0 or 1 place in its the direction of it, or it could be at the median. Do we have to reason by cases here? Are there properties of the median we could use to help us out here? Uh, sure. So, I mean, that was my reasoning before, right? Is if half of them are below and half of them are above, so moving the collection point away from the median can only make things worse. All right, so let's prove. All right, so the number. All right, so think, all right, let's prove a lemma about some distance too. So if it might be easier to work with the sorted list throughout. All right, what I'm thinking is we show the summed distance to z as a function. So if we move away from z, we're going to move away from the median. We're going to move an integer from one side of our collection point to the other eventually. And when we do that, then from then on, there's going to be more on one side. So if we keep moving, the cost goes up. So can we show that cost function? So what I want is sort of, the cost function is the distance is this, and show that that is greater than or equal to 0, and then our theorem follows by simple arithmetic. So all right, so if we filter L to those just above the median, except this isn't a true fact. That would have to be greater than or equal to. Unfortunately, I'm not really sure I have any good way to prove that either. Okay, well let's figure out. Let's figure out if our solution works. I'd really like to prove it works before submitting, but that doesn't seem likely. I'm not good enough at manipulating the proofs yet. Oh shoot, I did want that. Okay. If length grabs 0, then and some distance to L median. Okay. So I might be completely wrong, and so it would be foolish to try to prove it, but I'm pretty confident that this will work. All right, what's the example input? Sample input is that. Uh, all right, the sample problem matches. Okay, that's the right answer. All right. So I kind of expected this, that in part two, moving further is more expensive. So I really would like to prove this theorem, but let's but it won't apply to part two. In part two, it's probably going to be some other function. All right, so the function I mean, so this is just the arithmetic series. So the cost function of taking that many steps is just n plus 1 times n divided by 2. That's Gauss's formula, according to the no doubt apocryphal story of him summing the numbers 1 to 100. All right, steps plus 1. Multiply. So this becomes the cost function. All right, so we don't need these, but we do need I think we need to search in the absence of a better idea. So it can't be less than the minimum crab, and it can't be greater than the maximum crab. And I'm just gonna that's not what I want. So 19,000 or so, and 0, I imagine. Yeah. Okay. This feels like we should be able to do something smarter. That as we move one space, the cost functions are related, but in a way we'd have to do some sort of algebra to figure out. So everything at distance n becomes n plus 1, everything. All right. I think for 2,000 possibilities, we can just do the inefficient version, even if a more efficient one exists. All right. All right. Okay. All right, so there's our new value, and we want to compare that with everything else. All right, so if uh, we don't actually need that. Okay, so if L is if okay, well, else we want the minimum of V and the recursive call, which is not tail recursive here, but search value -1. Right, let min nat uh, does just min work? It does. All right. Oh, the problem is I had a comma in there before. All right, let's try it out. Oops, let opt equals min cost. We could return. Oh no, that's what we want. We just want the cost. We don't know where it is because we didn't save that. All right. Uh, 168. That's the right answer. All right. Well, that's good. We finished in under an hour. I kind of want to go back to part one though, because we actually got something where it'd be nice to have a proof that it was optimal. And it should be feasible. So what was I thinking here? I was thinking, can we can we show there's a cost function associated with moving away from the median? And the cost function is everything to the left of the median gets cheaper. Sorry, if we move left, everything to the left of the median gets cheaper and everything to the right of the median gets more expensive. Okay. So we could split it into moving left and moving right. That's not a bad idea, actually. All right, let's prove that sorting maintains. Let's prove that this function is invariant to the sort. So we saw an example that says it's a permutation in the library somewhere. Properties. Okay, so let's first prove let's first prove something of this sort. Some distance based on count. Except, we can't use for all x as a collection. It's just a okay, what we can say is if we remove everything with a particular value, yeah, what I'd like to say is if we sum up the counts of everything that's a member of the list, then we could apply this and say it's invariant under sorting. So I think it's easiest to say that about one element at a time. This may be a false step, but it's something I at least believe I know how I can do. So what we say is summed distance 2 of filter But that's going to be too hard to put the list back together. So we could write a function that returns just the unique elements. Or we could iterate over is there something that yeah, we need a set for that. I'm still not sure that would help us. What we want to say is I wish they had a different definition of permutation here, one based on ordering. Okay, could we prove that if this is true, could we say if the count between two lists is true? So say we have two lists. Can we say if this is true, then oops, requires summed distance to L1 meeting summed distance to L2 meeting. Maybe that's helpful. I guess I had another idea. Sum distance. The other thing we can do is show how changing the meeting value by 1, what the changing the meeting value by 1 does. So sort of distance to so if we got our list of numbers, so if we increase this by 1, then so all these get more expensive and all these get cheaper. So that seems like an invariant we could prove because it's got an inductive structure on the list. So we need to define num below and num above, which is actually partition. For the correct definition of partition. Okay. It's actually a little bit. Okay, so this has to be. This has to be those that are less than or equal to. So the ones that are equal get more expensive, and the nums strictly greater than. And so what does partition do? Whatever we want. All right, so num. Partition. X less than or equal to L. Uh, this isn't really a partition anymore. It's just a filter. So here we want it strictly greater than. Okay. So proving this inductively. So if it's a list of length 0, it should be trivially true because all those are 0. So let's check that. So admit just says, hey, assume this is true. Assume or more precisely, assume that the return value you need exists. Okay. But it only applies to that second case. All right. So otherwise, we inductively assume it's true for that. And then either one of these cases should be true. Maybe it can figure it out. Nope. Okay, so we have all right, we're getting everything right. So we have it for TL, and we need to prove it for L. So if TL less than or equal to meeting, what we need is this is equal to right. So if the head element is less than or equal to, then this relationship exists. Otherwise, we need to do both of them. Okay. And where's the parser? Maybe we need to wrap those in. Oh, there it is. I don't think that'll be enough yet. No. Okay, so we need to say the absolute value of TL of head minus meeting is greater, well, is equal to the absolute value of head minus meeting plus 1. Is 1 greater than that? No. Okay. So head is back here. Meeting plus 1. So there. No, it's still not enough. Some distance to L meeting equals These should both fall out. Oh no, okay. I got the lemma wrong. I want to say the opposite, or move these the other way. So I want to say if we increase by 1, then it's the same as taking the old value, and everything less than or equal to that gets worse, and everything strictly greater than that gets better. All right. So it would help if I was all right. Hey. So do we actually need any of this? Do we need to point it out, or? All right. Well, I guess that's a lesson for next time. Get the lemma right before figuring out why it can't be proved. All right. All right. So plus in the plus direction. Is this necessary? Oops. Oh no, we need to change those. Okay. So this is pretty close. So this tells us if we move away from the median, then we will increase by 1, and we can iterate to get multiple. Then it tells us what happens to the movement. So, okay, so can we prove at the median that these are I mean, they're not equal because they're imbalanced. I don't know. What do you think, Soul Viewer? Feels like this is the right direction. I think All right, so we can turn these in reverse and say if we're less than the median, then our solution gets better. Okay. Or at least doesn't get any worse. Okay. I think we need to show I'm worried we're going to have to end up proving the relationship between num LTE and num LT. Okay. All right, median. All right. What we can say is num less, all right, num less than L plus num greater than L plus number equal to L equals length L. I mean, this should be obvious because everything is in one of those categories, but I'm not sure it goes. Oh, num LT median L. I mean, this trichotomy should be true everywhere, not just at the median. So maybe we should prove that first. Yeah, all right. All right, I expect we're going to have to prove this inductively. All right, so match L with empty set, nothing, prove it to. Okay, took a while. I can prove that. Okay. So what we want to say here is something stronger. We want to say these two values are equal. And now I think we're back where I started a while ago on do we need to prove that sorting do we need to use this lemma? Or can we adapt this lemma? Is this even true? Yeah, because our median's not quite right. Was good enough to solve the problem, but we're not actually, this isn't true for this list, right? The median is, as we calculated, is 3. And so it's actually the case that that is true. So it should be fine. 3 and the difference between 3 and 4 doesn't make any difference to our puzzle. Okay. Is there another way we could calculate the median? That would be easier. Could we use a medians of median algorithm to, could implement a median of medians algorithm, but I think that would be a lot more complicated to reason about. It feels like the fact that it's sorted, maybe that's what we need. Like if we picked the median as our pivot, Hmm. Yeah, things that do not easily just prove by induction seem like they're harder in F star. It's a little bit of a puzzle here. So could we prove it inductively? Not without something proving something about the relationship with the median. Um, okay, so if we got a sorted list, do we know enough to prove that? Well, we can prove that the everything to the left of the index is less than it. And we're gonna need to write another lemma for that. I think. I don't know. I'm gonna have to sleep on this. Let's stick an admit there and see if we can prove it. Can we prove our theorem here? I think this actually isn't true. Right. It's not true because the median's here. So, all right. So we'd have a hard time proving that anyway, unless all the numbers were distinct, which is a very, very hard thing to express, I think. So our lemma would actually need to say that we're off by at most one. Uh, Yeah, it would be something like um, the ones that are equal are going to be split. But like in the first one that shows, there may be one less that is less than. Might be easier to do this for odd and even separately. So we know exactly when that happens. Okay, so we know what happens as we move away from median. One of these numbers to move in the positive direction, eventually the number less than or equal to is going to get bigger. Don't think we know how to express that though. Right, that this is not sufficient to say all right, I'm going to call it a night. I wish I could have proven this, but I don't actually know how. I mean, I could write the proof in English. I'm fairly confident in it now, but I can't figure out how to write that as a proof using the things F star knows how to express. So maybe after I sleep on it, I'll figure it out and talk about it tomorrow. I think we did pretty good with our lemmas here, but they may not be in the right shape to let us talk about it. Or it might be we need to express what the median does in some other way than this. All right. Well, thanks for hanging out with me. 2 hours is enough for one night, I think. So thanks again to all the organizers and sponsors of Advent of Code. Thanks to the developer of FStar for a fun tool to play with. And I'll see you tomorrow night.